You know, when you see an old building being torn down, what do you really see? A lot of us just see a pile of junk. But what if we're looking at it all wrong? Today, we're going to look at a digital blueprint that can take all that discarded wood and turn it from a huge landfill problem into a really valuable resource and a pretty powerful climate solution. And the scale of this problem is, well, it's wild. Let's talk numbers. Every single year in Canada, we're throwing out about 2.4 million tons of wood from construction and demolition. It just goes straight to the landfill. That's not just a massive waste of good material. As that wood breaks down, it releases methane, a potent greenhouse gas. So this brings us to the big question, right? What if we just flipped the script? What if we stopped looking at this as garbage that means to be hauled away and started seeing it for what it actually is? A resource that's just waiting for us to figure out how to use it. Now, the key to unlocking all this value isn't some single magic bullet technology. The real solution is a connected digital ecosystem. Think of it as a whole team of digital tools that work together from the very beginning to the very end of the wood's journey. So let's walk through exactly how it works. It all has to start upstream. And by that, I mean before anyone even swings a hammer or a wrecking ball. The very first step is to create a digital blueprint so you know exactly what kind of materials you're dealing with inside a building before you even touch it. The core technology here is something called Building Information Modeling, or BIM for short. The easiest way to think about it is like a super detailed 3D digital twin of a building. It maps out absolutely everything, giving us a precise blueprint, not for building, but for taking it apart piece by piece. And this is where it gets really cool. BIM lets you digitally tag every single material. You can see, okay, these are clean 2x4s versus those beams over there are pressure treated. This means you can plan a careful surgical deconstruction to save the good stuff. It's like giving a surgeon a detailed CAT scan before an operation. It even helps you spot problems ahead of time to make sure anything you salvage will meet today's building codes. Okay, so you've used BIM to identify all the valuable wood. Awesome. Now what? Well, once you've saved it, you have to be able to prove where it goes. And that brings us to the midstream part of the process, which is all about creating a rock-solid digital paper trail. And believe me, this isn't just about being organized for the sake of it. This is absolutely critical for the bottom line. If you want to get paid in carbon credits for saving that wood, you can't just say you did it. You have to prove it, measure it, and defend it with what's called a verifiable chain of custody. Now, chain of custody sounds a little intimidating and formal, but it's really just a simple 3-step process. First, you document the wood the second it's salvaged. Then, you track its journey in real time wherever it goes. And finally, you report its final destination, where it ended up, so a third party can verify everything. And how do you do all this? Not with a clipboard, that's for sure. It's all managed with web-based software. These platforms give you real-time updates and can even send you an alert if a project is falling short of its recycling goals. They're also a digital filing cabinet for all the proof you need, like photos and waybills. Plus, they help whole cities or regions track how well they're doing and compare their progress. And if you're thinking this all sounds a bit futuristic, it's really not. Over 500 jurisdictions across North America are already using systems just like this one to track their waste and make sure everyone is following the rules. This is tried and true technology ready to go. So this brings us to the final stage, downstream. This is where all that planning and tracking finally pays off. It's where you connect the salvaged wood to new buyers and turn all your hard work into actual revenue and those valuable carbon credits. So where do you actually sell this wood? Well, there are 2 main flavors of digital marketplaces leading the charge. You've got platforms like Reapply, which is the engine behind Ontario's materials marketplace. It's subscription-based, which works great for big manufacturers. But then you've also got a push for open source platforms, designed for smaller, local reuse centers, kind of like a re-Home Depot that make it super easy for anyone to search for materials. But finding a new home for the wood is only part of the puzzle. To really cash in on the climate benefits, there's one last super important digital gateway you have to go through. And that final gateway is the Credit and Tracking System, or CATS. This is the Canadian federal government's official mandatory platform. Basically, if you want to create official carbon offset credits, you have to go through this system. It's the gatekeeper. And this is where it all comes together. Every single piece of data you collected, from the BIM model to the tracking logs to the sales receipts, it all has to get uploaded into CATS. This is the system that checks all your homework and says, yep, this is legit. And then it issues the official tradable carbon credits that can make this whole thing profitable. Okay, so let's just pull back for a second and look at the whole picture. These aren't just a bunch of random tools. They're all part of a single connected workflow, a complete digital ecosystem designed to turn waste into real value. It all starts upstream, where BIM identifies what you've got before you even start. Then, specialized software tracks the wood's every move, creating that unbreakable chain of custody. After that, a digital marketplace finds that wood a new home, giving it a second life. And finally, the government's CAT platform verifies the entire journey, turning all that positive climate action into a real financial asset. When you put it all together, what this digital ecosystem really does is change our whole approach. We move away from that old, linear model of take, make, dispose. Instead, we shift to a truly circular solution, one where resources just keep getting used, creating value for both the economy and the environment, from stuff we used to just throw away. It's a really powerful model, and it's already happening. And that leaves us with one last big question to think about. If we have the digital blueprint to do this for wood, what other materials that are clogging up our landfills can we redesign from waste into value?